exponent rules. So we have a few rules, so I'm going to number these so that when I use them in the examples below, it's easy to see which one's what. So the first one is the zero exponent rule. So if you have anything raised to a zero power, that's automatically going to be a 1. Doesn't matter what it is. So for example, z to the 0 is going to be equal to a 1. All of this crazy stuff raised to a 0 will just simplifies down to a 1. Then we have the product rule, which I'll label number 2. So product means multiply. So when you have two bases multiplied together, so a to the m times a to the n, what that means is you're going to actually add their exponents together. So when you multiply bases, you add their exponents. So here's an example. 2 to the third times 2 to the fifth. They're both bases of 2 and they're multiplied, which means I can make it one base of 2 and add their exponents together. So 3 plus 5 makes 2 to the 8th power. Then we have the product of powers rule. This is also called power of a power, just depending on who you ask. There's lots of names for this one. Basically, if you have something with an exponent raised to another exponent, then you're going to multiply the exponents together. Something with an exponent raised to another exponent, multiply the exponents together. So here, 3 to the 5th, all squared, is equal to 3 to the 5 times 2, which makes 3 to the 10th. So the difference between these two rules is, on the product rule, you have two separate bases of a. On the power rule, you only have one base of a and two exponents. Then we have the quotient rule, which I will go ahead and label number 4. So quotient means division. So if you have two bases divided, a to the m divided by a to the n, that means you're going to subtract the exponents. Numerator minus denominator. So here's our tiny example. 3 squared over 3 to the 4th equals 3 to the 2 minus 4. 2 on top, then minus the 4 on the denominator, and then 2 minus 4 makes a negative 2. Now we don't like to leave negative exponents as negative exponents, and that's where our next rule comes in. We have the negative exponent rule. So for negative exponents, a to the negative m, what happens is we make this the fraction, and then it flips over. So whatever is negative moves to the other side of the fraction. So a to the negative m is now at the bottom, and now the m is a positive. So that's how you get rid of negative exponents. So let's look at that 3 to the negative 2. So 3 to the negative 2, this is really over 1. So this 3 to the negative 2 moves to the bottom, and the 2 becomes positive. Now, here's where this 1 comes from. If you have 3 to this 2 down here, well, what's left on the top of this fraction? We have to have the 1 there, otherwise it's a whole number if we just leave it as 3 squared. So we need to make sure we put that 1 as a placeholder if there's nothing on one side of the fraction. And then here's the last rule. It's not used all that often. It's really just an extension of the product or the power of a power rule. So if you have a fraction raised to a power, what that means is both parts of the fraction get that power. So a over b all to the m equals a to the m over b to the m. So here's our little example. So 3 over 4 to the 5th basically means the 5 gets applied to the 3 and the 5 gets applied to the 4 on both. So let's look at some examples. So it says simplify each expression below by using the laws of exponents above. Your final answer should have all numerical bases simplified. So for example, 2 to the 4th, don't leave as 2 to the 4th. Actually evaluate what 2 to the 4th is, which is 16. And you should have all positive exponents. Okay, so for example 1, basically we just need to figure out which rules we have. So right now I have one single base raised to a negative 3 power. So this is actually the power of a power rule. So first we're going to use rule 3, power of a power. And that says that if we have a to the m to the n, that means we're going to multiply the exponents together. So on this coefficient of a 2, the exponent is a 1. So if there's not an exponent showing, we assume there's a 1 there in its place. So that means we're going to multiply 2, and then this negative 3 and this 1 get multiplied inside the exponent. Then we move on to the x, which already has a power of 3, times that negative 3 power outside. Then we move to the y's, which already has a negative 3, times the negative 3 on the outside. And then we move to the z's, which already has a 5, times the negative 3 on the outside. So it's kind of like distribution, but only to the exponents. So now let's simplify this before we see if we can do anything else. 1 times negative 3 makes negative 3. 3 times negative 3 makes negative 9. Negative 3 times negative 3 makes positive 9. 5 times negative 3 makes negative 15. So now that I've applied number 3, let's see what else I have. Well, it says that I have to have all positive exponents. So right now I have a bunch of negatives. So we need to use that rule 5, which is the negative exponent. That says if you have a to the negative exponent, you're going to drop that to the bottom of a fraction and make the exponent positive. So I'm going to make this a 1, and I'm going to find all of my powers that are negative. So 2 to the negative 3 is going to drop. X to the negative 9 will also drop. Z to the negative 15 also drops. The y is fine because his exponent is already positive. It's y to the 9th. So on the top, we have y to the 9th because he was okay where he was. Now we're going to move 2 to the positive 3 on the bottom, x to the positive 9 on the bottom, and z to the positive 15 on the bottom. Last but not least, it said we had to evaluate all numerical bases. Well, that's talking about this right here. So 2 to the 3rd, well, that's 2 times 2 times 2, which makes 8. So your final answer is y to the 9th over 8, x to the 9th, z to the 15th. You know you're finished when you have one base of each kind, so 1x, 1y, 1z, and all your numerical bases have been evaluated. Let's look at example 2. Simplify this expression. So now let's look at it. We have a fraction, so that means I'm probably going to have to use that quotient rule because I don't see any parentheses. So we're going to have to start with the quotient rule, so that was number 4. And the quotient rule said if you have a to the m over a to the n, you subtract their exponents. That only goes for exponents. Coefficients do what they're supposed to do. So there's a 1 in front of this x. So you're going to have 3 over 1 times. Okay, now I see that there's an x on top and an x on the bottom. So we're going to subtract the numerator minus the denominator, so x to the 10 minus 5. There's a y top and bottom, so y to the 8 minus 6. And there's two z's, one on top, one on bottom. So 2 minus 11 in the exponent. So now let's simplify. Well, 3 over 1 makes 3. 10 minus 5 is x to the 5th. Y to the 8 minus 6 is 2. And 2 minus 11 makes negative 9. So we have all one base. We don't have any bases that are numerical and have exponents. It's just a plain old 3. But we do have a negative exponent here. So again, I'm going to have to use rule 5, and I'm going to use that negative exponent rule. So that means we're going to have to drop the z to the bottom of the fraction. So we have 3x to the 5th, y squared all on top, because those were positive exponents, and then z to the positive 9 on the bottom. Example 3. 3x squared y to the 4th z times 2x to the 4th y to the 6th z to the 5th. So I do see parentheses, so I might have that product of powers rule, that power of a power. But here's the thing with power of a power. See how there's this little n on the outside? I don't have a little number out here on either one of those parentheses. So that means you don't actually have power of a power. All these parentheses mean is that these two things are being multiplied together. So what we really have is the product rule. That was our number 2. So that said, if you had two items of the same base multiplied, that means you could add their exponents. Remember, this is only for exponents. Coefficients kind of do what they're supposed to do. So before I apply this rule, I'm going to rearrange everything. So multiplication doesn't matter what order you write it in. So I'm going to put all the like bases together. So first, I'm going to put the coefficients in the front, because that's what coefficients are. They're always in the front. So 3 and 2, and then times x squared times x to the 4th, just rewriting it, times y to the fourth times y to the sixth times z to the fifth. So before I actually apply my product rule, I'm going to reorder this and put all the like bases together. Now that all the like bases are together, let's go ahead and apply our rule. Well, 3 times 2, those are not exponents. Well, 3 times 2 is equal to 6. These x's are multiplied, so we're going to add their exponents together. These y's are multiplied, so we're going to add those exponents together. And the z's are multiplied, and now remember, if there's not an exponent, there's really a 1. So we're going to add those exponents together. So now let's clean it up. So 6x, 2 plus 4 makes 6, y to the 10th, and z to the 6th. So we don't have any bases with numerical and exponents. We just have a 6, and then all of our exponents are positive. So this is as simplified as this expression will get. Example 4. Similar to example number 3, except now there's no coefficients. So we have parentheses, so it could be the power of a power rule. But remember, there isn't a number out here on the outside of the parenthesis. So all of these parentheses are really telling us is that these two terms are multiplied together. So we really have the product rule again. So that means we're just multiplying stuff. So I'm not going to reorder it this time. So here's what you could also do. Instead of reordering it, just find your bases that are the same. So I have x squared times x to the third. So that means I'm going to add 2 plus 3 in the exponent. Then I have y to the third times y to the negative 3. So I'm going to add 3 plus negative 3 in the exponent. Then I have z to the fourth times z to the negative 4. So I'm going to add 4 and negative 4 in the exponent. So we're going to have x to the fifth times y to the 0, because 3 plus negative 3 makes 0, and z to the 0, because 4 plus negative 4 makes 0. Now the last rule that we're going to apply is actually the first rule we talked about, which was those 0 exponents. Anything with a 0 exponent is actually a 1. So what we really have is x to the fifth times, well, this y to the 0 is really a 1, times, well, z to the 0 is also a 1. So x to the fifth times 1 is just equal to x to the fifth. Number 5. So we see another fraction. So since we have a fraction and no parentheses, we'll probably be using the quotient rule. So that was when you had a fraction, a to the m over a to the n, you subtracted their exponents. So I see an x in the numerator and denominator, so I'm going to do x to the 12 minus 14. I see y in the numerator and denominator, so it's going to be y to the 8 minus 1. And then I have z's in numerator and denominator, so 7 minus 3. Okay, so 12 minus 14 on the x's make negative 2, y to the 8 minus 1 makes 7, and z to the 7 minus 3 makes 4. We're almost finished, except I see that there's this negative exponent here, so I'm going to have to drop that to the bottom of a fraction. So we have y to the 7th, z to the 4th over x squared. Now, as a little side note, if there is not a variable in both top and bottom, so if we have this example here, let's just say I'm going to call this 5.1. Oops, 1. If we have x to the third, y to the fifth over x z, for example. If I try to use my quotient rule, I see that there's x to the third and an x. So we're going to do 3 minus 1. But then the other two don't have any pairs. So we're going to put the y to the fifth back on the top with the x, and we're going to put the z on the bottom and leave it there. That way when you simplify, y and z had to stay exactly where they were. So if they don't have a pair, keep them wherever they are in the fraction. Top or bottom doesn't matter. Okay, example 6. Lots of parentheses, lots of little exponents. So with this one, I see parentheses, so I'm going to ask myself, do I have the power of a power? So do I have the a to the m to the n? And yes, I do, because I see that there's this little 2 out here on the outside. Now, this 2 only applies to this first set of parentheses. The second set of parentheses doesn't have anything on the outside, so we'll have to deal with him later. So right now, let's use this rule, the power of a power, and multiply their exponents. So this 6 is a coefficient, but it has an exponent of 1. So this becomes 6 to the 1 times 2. Then we have x to the 3 times 2, y to the 6 times 2, and z to the 8 times 2. Now all of this is still in parentheses because we have this guy on the right that we haven't done anything with yet. He still hangs out. So now let's clean up this blue spot before we start dealing with the entire thing. So 6 to the 1 times 2. Well, that's just 6 squared, which is 36. X to the 3 times 2 makes x to the 6th. Y to the 6 times 2 makes y to the 12th. And z to the 8 times 2 makes z to the 16th. And then again, bring down 6x to the 4th, y to the 6th, z to the 10th. Now, we don't have this power of a power rule anymore. What we do have is the product rule, where we add the like exponents together. Now again, this only is exponents, so this 36 and this 6 are not exponents, so those actually multiply together. So 36 times 6 makes 216. Then we have an x to the 6th times an x to the 4th. So that means I'm going to add their exponents together. Then we have a y to the 12th times a y to the 6th, so we're going to add their exponents together. We have z to the 16th and a z to the 10th multiplied, so we're going to add those exponents together. So if we simplify, we end up with 216, x to the 10th, y to the 18th, and z to the 26th. All exponents are positive, so we are finished. 7. I have a fraction and I have an exponent on the outside. So this is that quotient power rule, the very last one we talked about. So what this really means is this 3 on the outside gets distributed to both the numerator and the denominator. So this is really 15x to the 6th, y to the 3rd, z, all to the 3rd, over 5x, y to the 4th, z to the 6th, all to the 3rd. So this 3 applies to the numerator and to the denominator both. So now let's deal with one at a time. Let's work with just the numerator for just a second. So the numerator is now the power of a power. It has the inside exponents and a little exponent outside the parenthesis. So that means this 15 has a 1 on it. So we have 15 to the 1 times 3, x to the 6 times 3, y to the 3 times 3, and z to the 1 times 3. Remember, if there's no exponent, there's a 1 there that nobody writes. Okay, now again, on the denominator, this has the same rule. This has stuff raised to another exponent, so we're going to apply the same rule. So 5 to the 1 times 3, x to the 1 times 3, y to the 4 times 3, and z to the 6 times 3. So let us clean this up before we start talking about other rules. So 15 and then 1 times 3 is just 3. So 15 to the 3rd power is 3,375. 6 times 3 makes 18. 3 times 3 makes 9. And 1 times 3 makes 3. 1 times 3 makes 3 on the denominator. Well, that's 5 to the 3rd, which is really 125. X to the 1 times 3, so x to the 3rd. 4 times 3 on the y is y to the 12th. 6 times 3 on the z is z to the 18th. So now that we've kind of simplified things up a little bit, I still see multiple x's, multiple y's, multiple z's. So I'm going to have to use another rule. I see that they are in a fraction. So that means I'm going to have to use the quotient rule. That was a to the m over a to the n means I'm going to subtract their exponents. Well, coefficients don't get subtracted. These little coefficients up here are still divided. Those just hang out. Times. Okay, I see an x on the top and the bottom. So x to the 18 minus 3, y to the 9 minus 12, and z to the 3 minus 18. So let's clean up. So 3,375 divided by 125 is actually just equal to 27. X to the 18 minus 3 equals x to the 15th. Y to the 9 minus 12 makes y to the negative 3. Z to the 3 minus 18 makes z to the negative 15th. So last but not least, I need to make sure all my exponents are positive. So I have really over 1. So this guy's negative, he's going to fall to the bottom. And so is this guy. He's going to fall to the bottom. So it's 27 x to the 15th over y to the positive 3 and z to the positive 15th. Number 8. I have 5x squared, y, z to the third, all to the 0. Well, we have all of this stuff to a 0 power. Well, that means our answer is automatically just a 1 because there's nothing else besides what was raised to the 0.